All right, in this video, we're going to talk about independent events and probability. So you can see the definition of independent events are events where one event has no effect on the other. So the basic example we'll talk about is tossing a coin. If you toss a coin 2 times in a row, obviously the first time you toss it, you're either getting a heads or a tails. No matter what you got on that first toss, it's not going to affect the probability of getting a heads or a tails the second time. Both times it's 50-50. So when we look at this really basic example over here, if we flip a coin twice, find the probability of a heads and then a tails in that order. If you flip a coin twice, you have really 4 possibilities. You could get a heads and then a heads. You could get a heads and then a tails. You could get a tails and then a heads. And then finally, you can get a tails and then a tails. So what's the probability of getting a heads and a tails? Well, there is a 1 chance out of 4 possible outcomes of getting a heads and then a tails. The way we would do this with a formula is, well, we would take the probability of that first event. What's the probability of getting a heads in that first event? Well, it's a 1 out of 2 chance. And then what's the probability of that second event of getting a tails? Well, it hasn't changed. It's still a 1 out of 2 chance. And if we multiply these 2 probabilities, either way, we get 1 out of 4. But the formula is the shortcut way. And there's the formula. If you have 2 events and they are independent of one another, that is, the second event is not affected by the first event's outcome, then you just multiply the 2 probabilities together. Right here, this is not technically part of the formula. It's kind of a key phrase. It's not always going to be in a problem, but if you see the phrase with replacement, there's a really good chance that's an example of independent events. So let's look at just a couple basic examples, and then we're going to talk about dependent events in the next video. Example 1 says you flip a coin and then you roll a 6-sided die. You want to find the probability of landing a heads and then rolling a 2. So again, it doesn't ask for this, but good habit to get into. This is an example of an independent event for events. Because no matter what you get when you flip that coin, whether it's heads or tails, it's not going to affect the probability of rolling a certain number on a 6-sided die. So these events are independent, which means the form is pretty straightforward. The probability of flipping a coin and landing a heads is 1 out of 2. And then we're going to multiply that by the probability of rolling a 2 on a 6-sided die. Well, there's 1, 2 on a 6-sided die. There's 6 total outcomes. Multiply those 2 probabilities together. You get 1 out of 12. And then example 2. Here we've got a box that contains 5 gold coins, 4 silver, 6 copper, and 5 bronze. Here's that key phrase. Coins are replaced. If the coins were not replaced, think about it. If you choose 1 coin out of that box, that means you're decreasing the total sample size when you go in for your second pull. But here we're pulling a coin out and we're putting it right back in. So that means these are independent events because the probability in that second pull really doesn't change no matter what you pull out that first time, because you're putting it back in the box. This first one is an example of just simple theoretical probability. What's the probability of pulling a bronze coin out? Well, there are 5 bronze coins, and we're going to divide that by the total sample size. And the total sample size in this problem is 20, because 5 plus 4 plus 6 plus 5, all the coins added together gives us 20. So there's a 5 out of 20 chance of pulling a bronze coin, which of course reduces to 1 out of 4. The next problem, we want to know what's the probability of pulling something that's not silver. So there are 4 coins that are silver, which means there are 16 out of 20 that are not silver. And remember, if we pull that first coin out, we're putting it right back in. So the bottom number of the second fraction stays 20. The probability of something being not gold, well, there's 5 gold coins, so that means there's 15 that are not gold. And then we're simply just going to multiply these probabilities together. We're going to get 240. And you can reduce these fractions now, or you can wait to the end of the problem. Out of 400, and drop off the zeros, you get 24 out of 40. And then I guess 8 is the biggest number that goes into 24 and 40, so that reduces to 3/5. Encourage you to pause the video, try those last 3 on your own. I'll go over the answers here in just a few seconds. So the probability of not copper is 14 out of 20. Multiply that by the probability of silver is 4 out of 20. Reduce 7 out of 50 is your answer. So here's the rest of our answers. You just multiply that one out and reduce it. I think that's right, 1 out of 20.